Hey, welcome to video 7-3. We're going to be talking here on page 342 about using the triangle inequality theorem. Okay, so the triangle inequality theorem basically says in any triangle I can come up with three inequalities where any two side lengths of a triangle, if the triangle can be formed, have to be, the sum of those two sides has to be greater than what the third side is. And you guys, actually, we can summarize all three of these statements here, and just to go through the notation, AB and BC, those are the two sides, has to add up bigger than the third side. Then they change to BC and AC, have to be bigger than AB, and so on. What we can do, you guys, is we can summarize all of this information, and this is how I kind of want you to think about this, okay? Anytime you are looking at the side lengths of a triangle to figure out whether the triangle is possible or not, you simply say, does the sum of the two smallest sides end up being greater than the third side? Because if that's true, then all of the other inequalities will also hold true. It helps if you put your sides in your increasing order. So that the first two are the smallest sides, and then you can make up an inequality and say, is the sum of those bigger than the third side or not, okay? So this is what we did if you're just coming off of the class activity using our pieces of linguini and creating the triangles that were possible and not possible. We ordered the sides from smallest to largest in increasing order, and that's what kind of helped us through that activity. So if you can do that anytime you're presented with a problem, it'll help you. So let's go to the top of the next page, page 343. And here we're going to be using the triangle inequality theorem to tell whether a triangle can have sides with the given lengths. Now notice what they do is they create all three of the inequalities, but what we're saying here is in the summary, if you have sides 4, 8, and 10, those are already in increasing order. So really the only inequality I need to check out is 4 plus 8 bigger than 10? It's this first one. And if that is true, then as you can see, the rest of them will hold true as well. Okay? So for part B here, we're just going to do this first one. Is 7 plus 9 greater than 18? Again, do the two smallest sides add up to a number bigger than the third side? Well, that's 16, and 16 is not greater than 18, so we're going to put a big fat X there. And so our conclusion, without really even needing to do the rest of these, is that this is not a possible triangle. All right, so let's go through a couple of these reflex, because I think they're good this time. Can an isosceles triangle have these side lengths? Could it be 5, 5, and 10? Well, let's see. The two smallest sides there are 5 and 5, so we'll add those together. And the question is 5 and 5 greater than 10? And of course the answer is no, because 10 is not greater than 10. 10 is equal to 10, but it's not greater than 10. So number 5, how do you know that the triangle inequality theorem applies to all equilateral triangles? If we just did a quick little sketch of an equilateral triangle here, we know all equilateral triangles have the same side length, but even if we don't know their side length, let's just call it x. So any two sides is always bigger than the third. We would say x plus x has to be greater than x, and we're asking, is that true? Well, 2 times any positive number is always going to be bigger than a positive number, so yes, that is always true. And again, be careful that that's always true when you're talking about positive x values. Okay, so here I'd like you to do these your turns at the bottom of page 343, number 6 and number 7. Again, it may help you to put them in increasing order. Write that down so that you're not forgetting to do that, so that you can pull the smallest two sides and make your inequality that results. So take a pause in the video and do those two problems before we go on to the next page. Okay, and explain 2 here, I'm on page 344. We're trying to find possible side lengths in a triangle. So what you can see in the diagram up here where they're kind of drawing a compass is that if you're given 2 side lengths, and the 2 side lengths you're given are A and B, then a third side could really be anywhere in between where this radius of B would be drawn of a circle off of the end point of side A. So if you think about it, this point could move all the way around, okay, and still keep the defined lengths of A and B, but this dotted length side here for the third side is going to be changing, and it's going to be a range of things. So what's the longest it could possibly be? Think about opening up your triangle all the way flat. Then that third side would be A plus the radius B, but that would just be a straight line. And we can't have a triangle if it's just a straight line. So if it was just a tiny bit above that radius, then it would be a very flat looking triangle, but it would still be a triangle nonetheless. And it would be just under what the sum of A and B is. So the largest it could possibly be would be the sum of the 2 sides. The smallest it could possibly be, if we fold my triangle in the other direction, and we fold our point B closest down almost so that it's flat, we could have a triangle, let's say, right about here, which is just a little bit more than the difference between the two. Okay, again, we're looking for what's this third side. Well, it's almost A minus that radius B, but again, it can't be exactly that value, because if it were, we wouldn't have a triangle. It's got to be a tiny little bit more. So it's got to be between the largest possible value, which is the sum, and the smallest possible value, which is A minus B, or the difference. Now, if your A is actually smaller than your B, then you need to be careful and make sure that you take the absolute value of the difference, because you want it to be a positive number. So the range of values, you guys, is always between the sum and the difference, and it can never include those numbers. So here's how this would work as we're crunching this out. Look at example 2, part A. Find possible values for the length of the third side using the triangle inequality theorem that is above here, what we were just talking about. So it has to be between your third side, has to be between the sum of the 2 sides, because if I folded this out all the way, so this 12 was the radius coming out from the end here, it was 12 coming out this direction, then it would be 10 plus 12. But again, it can't be flat. So it's going to be almost 22, but not equal to. Notice, not equal to here, okay? And then it has to be bigger than, if I were to fold this 10 all the way up to the 12, so that this side x is getting smaller and smaller and smaller, the smallest it could possibly be would be 2, but actually a little bit bigger. So again, the difference, 12 minus 10, is 2, not equal to, but just greater than 2, and less than 22. And again, that's coming from 10 plus 12. Pretty simple, I hope. The book explains it a little differently. It goes through and it does all 3 different triangle inequalities. So let me just walk you through that. It says x plus 10 has to be greater than 12, true. X plus 12 has to be greater than 10, true. And 10 plus 12 has to be greater than x. So that's just using the 3 different inequalities from the triangle inequality theorem. And then it goes through and it solves these inequalities algebraically. So you get x is greater than 2, and we get x is greater than -2, well, that one kind of doesn't hold because we can't really have a negative value, obviously, for our side length. So we kind of ignore that one that comes out negative. And then also the other value is 10 plus 12 is greater than x, so 22 is greater than x. Now, if you take a look at what these two pieces come together as, you can see it's the same inequality that we got doing our sum on the upper end and our difference on the lower end. So there's lots of ways you can think through it. I just wanted to show you a couple of them. I personally prefer this way between the sum and the difference. So, for part B, if we were between the sum and the difference, we would simply take the sum of the two sides, so 15 plus 15, and that's our upper end, and x has to be between that and 15 minus 15. So it has to be bigger than 0 and less than 30. On the next page, see what you guys can do here with your turn number 9 and 10, figuring out the range of values. So that's a double inequality, remember, what we were just working with. Make sure you write it that way. And just a reminder, it's always less than symbols that you're using in double inequalities. Don't have those inequalities facing different directions, okay? It's like you were just to put that right on a number line, the lower number on the left, the higher number on the right. All right, take a pause in the video before we go on, please. Okay, in Explain 3, we're going to be ordering a triangle's angle measures given its sides. This is, again, if you've just finished the activity in class with Linguini, then this is using the side angle relationship we discovered, which is that the longer the side, the larger the angle is that is opposite that. So as we go on to page 346, in example 3 here it says, for each triangle, order its angle measures from least to greatest. So we're going to start by figuring out what is the longest side, and that's AC, and therefore opposite that side is angle B. So the measure of angle B is the greatest. The shortest side is AB, and opposite that side in the triangle is the measure of angle C. So if I'm going from least to greatest, I would go angle C, angle A, and then angle B. Let's do that for part B. For part B, the longest side length is BC, or 22. Therefore, the greatest angle measure across from it is the measure of angle A. The shortest side length is AB, and the least angle measure is the one across from that, which is the measure of angle C. And therefore, if I put the angle measures in order from least to greatest, the least would be measure of angle C, and then the measure of angle B, and then the measure of angle A is the greatest. Do these two your turns, please, 11 and 12, before we move on in the video to Explain 4. And Explain 4 is simply going to reverse the process. Okay, once you've done those your turns, as we're looking at Explain 4, again we're using this angle side relationship, so the bigger the angle is, the longer the side opposite it. Same idea as what we were just doing, but also kind of in reverse. So go to page 347, please. And in example 4, we're going to be ordering now the side lengths from least to greatest as we're starting with information about the angle measures. The greatest angle measure is the measure of angle B, and so the longest side length is AC here in part A. The least angle measure is A, measure of angle A, and the side opposite that is BC. So if I'm putting the side lengths from least to greatest, I'm starting with the smallest, BC, and then the middle side length is the middle angle, opposite that is AB, And then the longest side length is opposite the largest angle, so that's AC. Filling in part B here, the greatest angle measure is going to be 70 degrees, or the measure, using my stylus not quite right there, the measure of angle A, and therefore the longest side length opposite it is BC. The least angle measure is the measure of angle C, and the side opposite that is AB. So if I'm going from smallest to greatest, we're going to start with the smallest AB, and then AC, and then finally BC, which was my greatest. And do these two your turns, and that will round out this video, you guys. We'll see you next time.